Hello and welcome to this video in our assembly language programming. This will be the last video in this playlist as an introduction to this programming language. Again, if you're interested, you can check out the in-depth videos that I have on the channel, or you can check out there's another playlist on the the ARM instruction set architecture. So what I'm going to do here is I'm going to write a program, kind of summarizes everything we've done in this playlist so far. So what we did last video, we went over the branches and conditions, like comparison and conditions and branches. And what I'm going to do here is I'm going to write this entire program from scratch and talk a little bit about what we've done in this series from the first video, and then modify this program to actually count how many characters I have in my string and how many letter S that I have. All right, so if I was to start from scratch, like I said, we started with talking about directives, and we said that we have directives basically tell the assembler where to put the data that you have in the program in memory. And the memory can be either read-write or it could be read-only. And typically we'd like to have the instructions stored under read-only and the data of the variables to be under, so the variables are under the data, which is read-write, and the instructions are under read-only directives, right? And then here we have global underscore. We defined also a symbol. That's basically was the starting point for any program that you write for this particular platform. So underscore start, and then underscore start label, and whatever gets written between this start and the end is your program. You can also end this with the .end directive. Now, the data or any variables we have to use will go in here in this section, and then all the instructions will go in this section. And then we said that directives also can be used to tell the assembler what kind of how many spaces you need to allocate for the data that you have placed in memory. Essentially, what kind of data, which also translates to how much space you have there. So we said that we have the byte directive, the word directive, right? And we have the ASCII and the ASCII-Z. For this example, I'm going to stick with the ASCII-Z, and I'm going to write "this is my first program" as a sentence. And down here, I'm going to write a program to count how many characters in this string and how many letter S are there as well. So the first thing we said, we also went over the load store instruction, and in order for me to deal with these variables, I have to refer to them. I have to have a pointer pointing to these variables. In this case, I want to point to my message, so I'm going to set a pointer that points to the message label, which also means it's pointing to the first address of the first character in the string. And then I'm going to have to use a loop, right? I'm repeating what we did in the last video. So we did have a loop. And in that loop, the idea was we will grab a character, check if it's the end of the string. If not, we subtract 20 to convert it to upper string, and then store it back, update the pointer, and then loop back. In this example, I'm going to spice it up a little bit, I guess. Instead of just updating those characters to upper letters, I'm going to count how many there is of them and how many letter S's we have. So the first thing I'm going to do is, obviously, I'm going to load a byte. So we said LDRB will allow me to load a byte, and I'm going to store it in R1 from this location, which is pointed to by R0. Now I'm going to show you another way. Last time we wrote everything sort of in this in the body of this loop, but now I'm going to break it down into two subroutine, more or less. So I'm going to branch and link to another label that's called check. We can call it check something, or CHK to keep it short. CHK null check for null. So down here, I'm going to have another kind of chk null. And in this area, I'm going to check whether or not my character is actually equal to null. And how do we do that? We can use the compare instruction to see if the content of R1 is equal to the needed value of 0. If it is, I'm going to branch if equal. We also did this instruction. If this is true, we're going to branch to the end. Then maybe down here, I'm going to have a label called the end. Otherwise, if it's not the null character, what I have to do is I need to increment a counter. So let's say I'm going to use R2 to count how many characters I have in my string. So I'm going to add 1 to R2. So maybe I can initiate my R2 here as well. MOV for move R2, the needed value of 0. And this way, if it's not the end, if it's not the null character, I'm going to increment the counter, which is R2, by 1. And then I'm going to move or copy, in this case, the link register, LR, to the program counter. So that way I can jump back, or rather return from my this subroutine, the check null, back into the next instruction, which I'm going to have here. Now, ironically, the next instruction will also be a branch and link. And this time I'm going to branch and link to see if the letter is an S. So I'm going to call it chk S. Keep it capital, right? So that way I'm going to have to use a chk capital S. So this subroutine is going to check if I have an S that is stored into R1. Now, if I want to know if I have an S, I have to know what value do I have to compare it against. So I'm going to also use a compare instruction, CMP. I'm going to compare R1 against the value of S. Well, what is the value of S? So I can consult my ASCII table, and I find the letter S. S in this case, it's 73 hex, and capital S is 53 hex. So I have to do two comparisons. The first one is against the immediate value, hex value of 73. And if it's true, I'm going to add if equal. Let's say I'm using R3 to count for the number of S's, the immediate value of 1. And here I'm going to initiate also R3 with 0, right? Okay, what else? And I need to see if it is equal to 53. So I do another comparison of R1 against the immediate hex value of 53, add if equal R3 hashtag 1. So now I'm comparing to see if I have the uppercase S in there. And then if it's equal, I add 1, like I said, and then I have to move. I have to go back to where I came, where the call was made. I'm going to put the value from the link register back into the program counter, and this will take me down to this next instruction I have in my loop. Now, here, all I have to do is I have to branch unconditionally back to loop. So basically, I'm going to grab a byte, check if it's the end of the string. If not, check to see if it's an S. If not, I go back to the loop. Well, what happens if it's the end of the string? Inside this check null subroutine, if it's equal to the end, or if it's equal to the null character, I'm going to branch to the end. So this loop will only break if this condition is true and it branches to the end. Now, there is one more thing that we need to do here as well. I showed you last time that we can increment the counter by adding 1 to it. We did talk about working with different types of values. If you have bytes, you add 1 to the pointer, so you go to the next byte. If you have characters, you also add 1 because each character occupies a byte, and so on. If you have a word, you add 4 to the pointer, and so on. Now, I can do this if I want. I'm going to add 1 to R0 and add 1 to R0, and this will advance the pointer by 1 before it loops back. This will work perfectly. And I'll show you another notation for this load byte, and we'll compare the two ways, okay? So let's compile and run this. We can step through it. So you can click on step over and see these values being moved into these registers, right? Now I'm grabbing the first value from R1, or actually did I make a pointer? Yeah, there was a pointer there. I'm loading the first value from R1. Where is R0? R0 is 48. That's what I was looking for. 48, that means my string started here. This is right here. So 74, that's the T, right? The value for T. So I'm going to step over it. Then if you click on step over, it will go execute this subroutine and come back to the next instruction. If you want to see what this subroutine does, you click on step into. So if I let me show you actually. So if I click on step over, it performs this branch and link. It will go through these instructions and come back to the next instruction. If you want to see what happens within the subroutine, you click on step into. So I'm going to do this here. So now it took me to the check S subroutine, and within this subroutine I can also step over. So I'm going to compare against capital S or lowercase s. It's not, so this should not execute. R3 should not be updated. It stays 0. I'm comparing the value against uppercase S. This also does not execute. I'm sorry, it will be null. It will be not equal, and this instruction will not execute. So R3 is still not updated, and then I'm moving the values from the link register into the program counter with this move instruction. So now I'm going to come back to this add instruction that was under my two branches. So if I click here, I'm coming back to this instruction, right here. Okay. Notice that actually my counter for the number of characters in the string has been updated by the first branch and link, and so on. So I can iterate through this one more time just to see, or maybe a couple more times until we hit the S, right? So 4 more times. We can do that manually, or we can semi-manually, kind of. We put a breakpoint here before we loop back to the next iteration in the main loop and click on continue. This basically says every time I grab a character, I check against the null character and I check against the S character. Before I go to the next one, I'm going to break. So I can click on the continue in this case. So I'm assuming in this one, it's comparing against the I. And then if I click on continue, actually this is the I think. And then this one is checking against the S. I've encountered my first S in this case. And then I click on continue. This is doing the space. This counter did not update. Continue. This is the I. This did not update. Continue. This is the second S for the is. That's in the is, and so on. I'm going to remove this breakpoint and let this run. Continue. And then if I examine here, oops, I'm gonna stop it and go back to my, it doesn't matter actually, either my editor or the disassembly. So this tells me that the number of characters in the string are 18, and then the number of S's in the string are 3. So let's double check and see if that's true. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 10 hex. Then 1, 2, 3, 4, 5, 6, 7, 8. So that's 16 plus 8 hex, so which is 18 hex, right? And then how many S's do you have? That's true. I have 1, 2, 3 S's in my program. Now, The last thing I'm going to do here is, like I said, I'll show you this modification for that instruction. Instead of having to add that one in a separate instruction, I actually can move this one to here. And what this does now is it's going to grab a byte from that location. And then after that byte has been read, the pointer will be updated by 1. Okay, so this notation will actually add 1 to this pointer after this instruction executes, or after the byte is read rather. It's just another way to work with these load store instructions. There's a way to offset the pointer by a fixed number. You can offset the pointer by another value that you take from another register, and so forth. But anyway, this is meant to be sort of like a put together cool program to count the number of strings in a to count the number of characters in a string and the number of s's in that string, store them into 2 different registers. It showed you how to use the directives, how to use the ASCII or the ASCII Z rather, how to use the move instructions, the load instruction, branch, do a comparison, and then based on the results you can get the instructions that follow, execute or not. And this is it. I hope you enjoyed these videos. They're kind of like a quick class on ARM assembly language programming. I hope you're able to either follow through with the coding, either follow through while I'm presenting, or maybe you want to give this a try on your own and play around with it. And give it a shot. See if you enjoy doing some coding in assembly. There are going to be some other videos posted as well, but from the perspective of the quick introduction and a beginner aspect of ARM assembly language programming, this is the last video, but there will be other videos with some other cool programs. So if you are interested, feel free to follow and like this video. Hopefully you've learned something, and I'll see you in other videos. Thank you for watching.